I was not aware. I wasn't aware we're using Zoom today, so sorry for the delay. I was trying to connect to the Teams all this time now, so um, I think let me share my screen so that we can start. Okay, so the course rep is here. I believe my voice is loud and clear. Is my voice loud and clear, please?
Yes, sir.
Okay, good. In case it drops, kindly let me know so that I can just match up my voice. I hope let me see the class, the number now. The number here now is the class is supposed to be 30. Because
Yes, sir.
okay, so you have the 30. Okay. All right. So if you guys remember, the first day we met, when I was going through the course outline, I did mention of a grouping, a group work which you'll be presenting. This is the course outline. Week 11, the face to face, the last face to face we'll be having, we'll be doing presentation. I hope you guys remembered we did talk of this during the first day we met. Are we here? Hello?
Yes, we are.
Okay, so I think we are almost in the middle of the semester. We are almost, we are not there, but I think from next week, after we go through the asynchronous, midterm will start, then we prepare towards the exam. So I think it's best I do the groupings so that we all know the group we fall in, so that you can start preparing before the time. The earlier the better. You guys told me I should do the list. Like I shouldn't allow you people to do the list, so I should group the list. So I've done the grouping. This done. This is the grouping. I'll be sharing it with the course rep. I'll be sharing it with the course rep so that the course rep can share it in your WhatsApp platform so that you know which group you belongs to. So this is the grouping. Okay. So we have group A. We are 30, so at least five in each group. One, two, three, four, five. Five in each group, so that at least if there is any disagreement, the last person will decide. So we are going to have six groups. Okay. So six groups, that's group A to group F. But I told you I want you guys to change the grouping name. So later when you finalize the grouping names, you can communicate to the course rep so that I change it on the system. I've created a group name on the LMS where all of you have been posted into your group. So currently we have group A. We have only Enoch to Michael. Then we have group B. We have group C. Group C, one, two, three, four, five, six. Okay, there was a plus one somewhere. So, okay, so this group C. Oh, one, two, three, four, five, six. So I think you have a plus one. In case any of you are course rep, in case there is someone in the grouping that is not part of you, or probably the person didn't enroll or the person deferred, kindly let me know, then I'll rectify it. Okay. So, course rep, if I give you the list, kindly do that. If there is one or two people who are not in the list, maybe all of them have belong to one group, so I can just reshuffle. So currently, this is the groupings. Okay. And it's in five groups. So what each group will be doing is from group A, or let's maintain the group A. We shouldn't change it. Let's maintain the group A so that we divide. So group A will be taking the first topic. Okay, basic of computer network. Do your own reading, prepare your own PowerPoint presentation. Then you come and present. And the presentation is going to be 10 marks. So just keep in mind, it's 10 marks. Last week, I was supposed to give you an assignment, but I decided to hold on and add all the quiz to a midterm. So we are going to have a midterm that's going to be 20 marks. Then the presentation is going to be 10 marks. Then the final exam is going to be 70 marks. Okay, so group A will work on the basis of computer network. Group B will also work on internet and concepts and protocols. Group C, cybersecurity and fundamentals. Group E and D, malware and data protection. Group E, ethical and legal issues of computing. Then group F, emerging technologies, cloud computing, IoT, and AI. So this is the groupings. So it's better you start on time. After you are divided, after you get the list, you look for a course, you look for a leader who will just put you together. Maybe you form your separate WhatsApp group beside it. Then you can have your own discussion, start putting things together before the time. And before you do your presentation, before the face-to-face, I'll create a submission link on the platform, which you have to submit your PowerPoint on in there. So every group leader will submit the PowerPoint on the platform. And so that I'll have a copy of it before you do your presentation during the face-to-face section. I hope you are following. So within the third week, I'll make the submission. I'll try and create the link available now. So in case you guys finish on time, you can always go there and upload it so that I have. Maybe there may be certain things I'll cover that is not in your PowerPoint so that you can have a fair idea, fair knowledge about this particular topic. Any question on the week 11 face-to-face? Any question? Okay, so if there's no question, I think we are now. So, Constrep, after the section, I think I'll share it with you on WhatsApp. I'll share the listing so that we can do the rectification in case one or two people are not available. We just put in there. Then, in case maybe we have someone who, I think, if we have a colleague who is not in the country, you can just let me know so that I know what to do.
Yes, sir. Please, you have one.
Pardon?
We have one.
You have one. Okay, so Constrep, after the section, you just let me know. Then I'll try and look at that one. Even though the person is not in the country, that the person can still contribute in the group discussion. The presentation, if the person is not here, no, I mean, we are five in the group, so the four people can do the presentation. But I have to be sure that that person was part of the discussion and everything you are presenting is input or input is part, so that the 2 marks that will be awarded will go across board. I hope you are following. So that shouldn't be a problem as far as we have other set of team members in the country. All right. So thank you. I think we can move on to today's topic. How many of you have visited the platform this morning? How many of you have gone to the LMS this morning? Okay. So I just went through the platform and I noticed only few of you have watched the introduction videos. I'll urge you all to try and watch those videos because those videos sometimes even summarize everything. If it's certain things that maybe at the end of the day you didn't understand certain things, you are going to get that probably knowledge from those videos. And I actually take time to prepare those videos for you. So if I'm preparing and no one is watching it, I'll feel a little bad about it. So all of you should try and watch the overview videos. those who haven't watched in the past, at least try and watch it. I have the overview video for this particular one. I'm not going to play it because it's on your platform. I urge you after the section, you can equally go back and play it and listen to it. And I think it's 5-6 minutes. Okay. All right. So just that. Okay. So today we are looking at central processing units and the memory system. And in the last week, we look at the general overview of it. We spoke about some of the top things we are coming to talk about today. We handled it last time. But this time we are just going to focus on it and just delve into it and go deep into the central processing unit, then look at the memory. Then next week we'll take another component. Before we are done, then we've taken the whole system, the computer system as a whole. So if last week there is certain things you didn't understand, I'm sure as we go into details here, you are going to catch up and understand some of the things you didn't get last week. Okay. Also, I've created a book for this particular section. It's on a platform. I think I have to do a little small changes. After the section, I'll try and do the changes and make it visible. It was there, but I noticed there were some few mistakes, so I decided to hide it. So I'll do those and make it. So that's why I said the book go in hand with the PowerPoint. Certain things are in the book. I may not say it whilst I'm having the presentation. It will be an oversight, or I would think it's negligible. But when you read the book, you are going to get all those gaps, to bridge those gaps, and you'll be fine. Okay. And I'm sure those of you who have read the book can attest that the book is really self-explanatory. If you read it, you understand everything. Okay. So just the only thing is that there's no pictures in there. But I'm sure as you are reading, you're able to visualize some of the things there. Maybe in the future, if there's more time, I may go and put in some few pictures to some of the things which you can probably visualize and relate to whatever that particular paragraph or section is talking about. Okay. Also, I got a feedback from one of your colleagues that sometimes when I'm teaching, I talk very fast. So they want me to sometimes slow down a little. So I'm trying to do the slow pace today and see whether it will be better or not. So after that, I'll get a feedback from whether that's the speed you want or you still want me to move very, very fast. Okay, so we'll be looking at 3 sections of this particular model. We'll look at the deconstruction of the CPU core, analyzing the processor type, then understanding primary memory, then mastering the memory hierarchy. So basically, this is what we are coming to look about. We are coming to talk about for this section. Okay. So the last week we spoke about the part or the units that will have the CPU, where we talk about the control units and the ALU and the registers, which we spoke about. We also spoke about their functions, but we didn't go deep into it. Okay. So basically, today we are going to focus, this particular session is going to focus basically on the CPU. So I think last week we spoke about the CPU as the main brain of the computer. That at least it controls everything you do on a computer system. Basically, is the CPU that executes all those instructions you give to the computer through the input devices, which we covered the last time. Okay. And also, I made you understand that the CPU doesn't work in isolation. It works in a team with the memory, the hardware, the output, everything works in hand. Without the and last time we also spoke about this component that is in the CPU. So we spoke about the control unit, which I said that is the supervisor. I made that statement that is the supervisor that supervises basically everything the CPU does. It's just the supervisor. Then we have the ALU that deals with what? The arithmetic or the comparison or when it comes to calculations. So the control unit is responsible for redirecting the operating system of the entire computer system. So it just controls, sorry, the control unit, it controls and redirecting the whole computer system. It acts as a supervisor that manages how instructions are executed and how data flows between different components. So we look at that if you input something, it's the CPU that takes it, process it, and give it to what? The output. And even though the CPU does it holistically, the person in the CPU or the part or the component in the CPU that does that is the control unit. So you just have to make sure you know all of them and their characteristics and what they do. So that when question is asked, if it's a generic question, you can just say CPU. You choose the right answer within the CPU that does that particular task. Okay. So the control unit performs several important functions, which we explained the last time, that it retrieves instructions from memory, it interprets the meaning of those instructions, then it sends control signal to other units, which we spoke about the last time. Then I think we also spoke about the ALU. I'm trying to relax about it because I'm sure I don't know whether last week we have someone here who didn't join the face to face because, as you said, you have someone who is outside the country, so the person didn't get a chance to join the face to face. So I think if he listens from this part, I think you will understand all facilities we spoke about the last time. And also maybe some of you also joined late, so you made some portions of our discussion. And last week was face to face. There was no recording. So I think me coming back and climbing, it will be beneficial for those who were not available at that crucial time. Okay. So we spoke about the arithmetic logic unit, which we said is the calculator. Okay. So what it does is the arithmetic, commonly known as the ALU, is part of the CPU responsible for performing mathematical and logical operations. So mathematical such as addition, subtraction, multiplication, divisions. Then it's also that logical operations. Logical operations, we are talking about comparing values, determine equality. Okay. Then also look at the less than and greater than operations. And also talk about the or, the nor, the so, XOR, the not. Okay, so those operations are done by the ALU. Okay. Then from there, we also look at the registers, which all these three components are inside the CPU. We look at the registers that we said that it refers to what? A small high-speed storage location inside the CPU. So it's just a storage inside the CPU. And what it does is it stores instructions temporarily. And it stores instructions that are being processed at that particular point in time. So when the CPU is processing something, the register stores that particular data which is being processed at that point in time in the registrar. So the registrar is very small and it doesn't have a lot of bigger space. So when the CPU is processing, it stores it temporarily. And what it does is after the CPU finish processing, it pushes it to the memory, the actual RAM, which we'll look at it when we are going to the further part. I think we are doing the breakdown. But I just want us to know that after I finish processing, it goes to the RAM, put it to the RAM. Card or your pen drive, or even if there's a cloud storage, it stores it to the storage. Okay. So the registers serve as what? The storage for when the CPU is processing anything. And it is just get in mind, the key point is that it keeps it temporarily and it has what? A lower storage capacity. So it can store things and huge stuffs. So that's what the registers does. Okay. fast, limited capacity storage, located direct inside the CPU for immediate data access. So that's what I've explained. And I assume the slide is also explained more. I'm not using this, I'm just using the slide, but I'm just explaining so that when you read the slide and you add the book to it, then you get everything in full. Okay. So that's basically the central processing unit, the CPU that we already know. These are the three main components that are inside the CPU. Okay. Now, the CPU goes through a cycle when it's working. And I think we spoke about this thing last time too. It goes through an infinite loop when it's processing something. So it first goes through what we call the fetch, then it decodes, then it executes, then it goes through the fetch. So it goes through in a cycle. And it is done extremely fast that you can't see within a second. That last time I made it that if you have a processor that is 1 gigahertz, if you see 1 gigahertz of a processor, what it does is it does this cycle 1 billion times every second. That's what it means. Every second it does the cycle 1 billion times. So I think the last time we spoke about the reason why you need to have huge processors in order for it to be more efficient when you are working with bigger softwares or applications. Okay, so it does fetching, decoding, execute, then the cycle goes all over again, all over. So these are the three infinite loop the processor goes through anytime it's working. So if it's not working, you have your machine on and you are not doing anything, it's not doing that. But as soon as you start doing something, clicking something, typing something, then you activate the cycle loop. So just keep in mind, if the machine is just on, the processor is not doing it, unless maybe there are some programs that are running at the background of the system. Now the processor will still be working on it. But in case no application is working, the processor also waits for instructions. Okay. So when we say fetch, what does it mean? Okay. So when we say fetch, what does it mean? So fetching just means the CPU retrieve the next instruction from memory. So what the CPU does is it goes into the memory, look at the next instruction, give it to the control unit to interpret the instruction. The control unit decodes the required action, then it executes the CPU to execute it, whether through mathematics or logic or data movement. Then after that, it goes back into the memory. So it just goes through that cycle. So when we are fetching, when we made fetch, the division of fetching is when the CPU retrieve the next instruction from memory. Okay, it goes into the memory to look at the next instruction or the instruction that has been given. Then as soon as it does that, it goes back to the memory again. So what the CPU does, even when it's executing, so it does it very fast. So you have just entered a command to the computer system, but the CPU does this multiple times within that short time. Okay, then we look at the decoding, then execution. I think this point is also very, 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 very clear. Okay. Now, the operation of the CPU. Okay, so we have what we call the system clock. Okay, which I've already explained a little that when the CPU is working, if your processor speed is 1 gigahertz, then we are talking about 1 billion per second. If it is 3 gigahertz, we are talking about 3 billion per second. And I know most of you have higher processor speed. Sometimes you don't even check. Some of you don't even know how to even check. If you want to check and you're using Windows, you just click on probably my computer, you go to properties and you see it. Or you can use the run and type DS diagnosis, and that will also take you to the page. You can see all those character or features of your machine. So like I know which processor you are running, your memory type, and the rest. So the operating system of the CPU synchronized by a component known as the system clock. So when it's synchronizing, the component one was the system clock. The system clock generates regular pulse that controls the timing of operating within the CPU. Each pulse of the clock represents a cycle during which that's one clock cycle. My internet is not. Can you hear me? I'm getting feedback that the internet is not stable. Can you hear me? Hello?
Sir, it breaks at a point.
Yeah, because I'm getting some feedback here. Okay, so in case it breaks, kindly inform me, okay, so that I'll know because I'm having a little unstable internet at the moment. Okay. So higher clock speed, when you have a clock speed, the higher clock speed results in what? Faster processing. Although that is not just the basic factor you need to take in consideration to know that a system is running faster, but it also helps. It's also part of it. Okay. Then we have the multi-core architecture. So currently modern computers, okay, modern computers currently are using this multi-core architecture, and almost all the machines, the Pentium, the Intel Celeron, which is just one processor or one core, which is on the motherboard. But now, because they want computers to what? Run faster, we've gotten to the where modern technology have expanded the functionality so that the computer can run faster, and it's taking into consideration the multi-core architecture. Okay. So the multi-core architecture talks about having maybe two or more processors embedded in one processor. Okay, so you see it as one processor, but we have two or more cores of them in it, and they work in parallel. So if one is probably playing music, and as you are watching music, you want to also and that helps with what? Multitasking. And it helps what? The PC to do multiple things at a time. The earlier PCs like the Windows 5, the 2000, they were not having this multi-architecture. So when any of you have used Windows before, those days when you open, maybe you are playing a game and you decide to open another thing, it's like the machine will be struck because you are doing multiple things, and one processor is trying to share the resources to do multiple things. Either one will close, one will freeze, or the machine will freeze all of a sudden. Sometimes you have to close one program running before you run another program. Okay. Multiple chips or core chips in one processor architecture. So we have what we call the dual core. And I'm sure most of you have heard of the dual core, and as at now, maybe some of you are still using dual core computers. So when we talk about dual core, it's talking about two cores. So two cores in one. So you see the processor as one, but it's two in one. Then we have the quad core, which is 4. We have the octa core, which is 8. We have the hexa core, which is 10. But when you come to the octa and hexa, then we are talking about higher speed machines that people are using, like servers and those who are using it for maybe video animation creation, wild video editing. That's when they go in for what? The octa core and the hexa core. But I think the quad core and the dual core, that one, most of us have seen it, and most of us have computers that are using such processors. Okay. So that's also one factor that helps or boosts a computer to run very, very, very fast. Now we spoke about the CPU components. We talk about the ALU and the rest, but what are their importance? What are the importance of those components. So the components in the CPU work together to ensure that instructions are executed efficiently. The control unit manages operations, the ALU performs what calculations, and the register provides fast access to what data. So basically, that is what they do. In summary, that's what they do. So if a question is asked about the importance of what all the three computer system components, this answers it all. As soon as you write this point, you've gotten all the full mark. So we've spoken about processors, but we have different types of processors. Okay, it's not just one processor, we have different types. So we have um, the general purpose processor. We have different types. We have the general purpose processor, and basically the general purpose processors are like the Intel, the AMD, and they are we call it general purpose because they are used in computer systems that are used for general purpose, like the one we have on our computer. You can use your computer to play games. You can use it to solve mathematics. You can use it to browse. You can use it to play music because it does different purpose. So the processors that we have in those kind of devices are called the general purpose what? Computers. I hope that one is surface computers. Then we have the microprocessors, which I don't have here, but I think it's in the book. We have the microprocessors that we have in the CPU, which we install on our desktops, our laptops. We even have some that we install in our mobile phones and other tablets. So our tablets, our embedded systems, our microwaves, and other systems also have processors in them, but not the same as what we have on in our computers or our phones. But the same thing, they are there to help process something. Okay, so just keep in mind that the microprocessors that are used in the general computers, we have another versions in other devices, but probably they've been created for what different purpose. Okay. Then we'll talk about what the GPU. I think the last time we spoke about the GPU, which um, the GPU stands for what graphic processing unit. So it's also a form of processor because it processes what does is it supports the processor, the actual processor we know, so that the workload of the processor will come down. So it's also another form of processor. So we have the GPU, which if you are a gamer, that you need those particular processor as part of what the general processor you have to help you what process things that you'll be using very faster and what much effective. So we have that one. So the CPU that we know and the GPU work hand in hand. They don't work in isolation. What the CPU will do its tasks, give it to the GPU, and the GPU also continue. So I think the last time I I showed you those who are in class, I showed you one of the GPU that was in the system unit I brought into the office. So usually some people call it video card, video card, video card. So that's what some people call it. But its actual name is was GPU. Okay. All right. So just keep that in mind. Then we have the processors that are used in embedded devices, like as I said, the embedded processors. They are usually used. They are specialized processors that are designed to perform specific tasks within a dedicated system. So, like the automobiles, the home appliance we have, you have a microwave. You use it to warm your things. So we have these embedded processors in there that helps it to process the instructions you give it. If you want it to be warm, to do the warming for 5 minutes, you give the instruction and it follows that instruction. If you want it for 1 hour, and we even have a microwave that does grilling. If it's chicken, You know where to set it. It communicates to it, and if it's supposed to grill the chicken for 2 hours, it does that. If it's pork, we'll do it for 4 hours, it does that. If it's fish, which is 30 minutes, it does that. So all those are what embedded processes. And as I said, I have it in the book. So sometimes if I didn't cover it here, you look into the book and you can read and understand that particular one more. Then we have the digital signal processes. So digital signal processes are used when we are talking about you want a real-time data. Real-time, you work the system or the device you are working work with real-time data or continuous data. So when the device or the computer system use real-time data, then the processes that are stored in those are what? The digital signal processes. So we have a simple one like the one we have on mobile phone. So you want audio, you want to listen, you want to talk for the person to what? Get a feedback instantly, and it's supposed to be what? A synchronous way of it. So that's why the telcos usually uses that particular signal, digital signal processor. So most of our phones and most of the devices that we use for roads are walkie talker and all those things, they use the digital signal processor. It has been embedded in it. So as I said, we have different processes and what they do. Then we have the last one that we call the application specific integrated circuit. That's the ASICs or ASICs. So it stands for application specific integrated circuit. Okay. So these are processes designed for specific applications or functions. Unlike the general purpose processes, these particular ones perform tasks, making them highly efficient for that purpose. So example, we have something like the network router. The network router is it runs on the application specific integration circuit. So that one, you know that if you have a network router, the purpose of that router is to just distribute whether internet signal, whether through Wi-Fi or through the LAN. That's basically the purpose. It doesn't do anything again. If you have a switch, that is its purpose. It can't do any other things apart from doing what's supposed to do. So those are examples of the ASICs the devices I'm talking about. I think you go through the book, there are more examples. You can really look at. Over here we have the crypto mining. The crypto mining, most of you don't understand. That's why the network router will be the easiest one for you to understand. Okay. Now, there are certain things you need to look at when assessing or going in for a processor as an IT student or an IT expert. You people are going to be the IT expert for the future. So there are certain things you need to look at. Someone will come to you that I need to buy a computer. What will come that you should be a consultant. You are going to be a consultant. Then tell the person what the person will need. So there are certain things you really need to look at. Okay. So when you are selecting a processor, certain things that you need to look at is one, the processing speed. So you have to look at the speed of the processor. So if someone comes and the person wants a computer and there are different computers in front of you, you need to check all of them. Look at the processor speed. Then you look at the number of cores, whether it's core i3, core i5, dual core, quad core, and all. You have to look at the cores. Then you look at the power consumption. Okay. Then we have look at the cost, the compatibility of with other hardware components. So these are basically some of the factors that influence a processor if you are looking forward. So example is like if in a gaming system, if someone is buying a gaming laptop, okay, not all of them the selections I give or like the components I give as in the processing speed number It's not all of them that will apply for a particular device. Maybe for some devices, you may need to look at the processing speed, the number of cores. You don't need to look at the power consumption. In some devices, probably you may not look at the number of cores. You have to consider probably the power consumption. Because we have some processors in mobile phones. You have some processors that drains battery, especially for the early versions of iPhones. It drains battery. Any iPhone user, all the time, he has charger around. If anywhere is going, you have charger in his bag. Because their processors drains battery. If you are using iPhone and you on your data, your actual phone data, before you realize your battery will just be dropping, blah, blah, blah. But if you're using a wireless, the battery keeps longer and so. It's different from the Android phones, which you can charge and you can sometimes use it for days without charging, days before you can recharge it. But for iPhones, sometimes it's even difficult for iPhone to take you 24 hours without recharging. So if it needs to work, thereby draining the power of the device. So you have to look at it. But when it comes to computers and desktops, sometimes you don't look at the power because you always run it charge all the time charge. Even those who are using laptop are always even using the laptop charge. Even though the battery is there, they always want, even if the battery is there, they want to still charge. So for the laptops, we may not look at what the power consumption. But when it comes to other devices like phones and other stuff, you may try and prioritize power consumption before looking at other stuffs. Okay, so basically that's it. So example, if someone comes to you that okay, so I need you, I'm building a gaming machine or a gaming system. You need to tell the person what to look for, what a multiple core, like multiple core processor machine, because the person is a gamer. Okay, and also you have to tell the person that you should look for what a machine that has what a GPU that's higher what graphic processing. Okay, so you tell them look for GPU, either NVIDIA, then you give the person the NVIDIA number, so that when the person is buying, the person will look, so okay, I need to look at this, because I'll be playing FIFA on it, I'll be playing this on it, I'll be using it to do one video editing. Okay, so that's it. And also, if it's a mobile device, the mobile device require the consumer will require a processor that consume minimal power while maintaining what acceptable what performance. So as I said, the earlier factors I spoke about, is not that if there are five, then all the time the five have to apply. Sometimes two or three will apply. But you may meet a device that probably you have to go through, you have to checklist all what the five um, factors. Okay. So I think we've spoken about this. So we have the mobile processor. I think it's part of, as I was talking about it, I think I talk about it, we don't even get into the slide. So we have processors in mobile devices, okay, and which I've already specified. And the processor in mobile devices, usually they are supposed to have, they shouldn't consume much power. Okay, so that's one of the characteristics of mobile processors. They shouldn't have enough power, because if they drain on enough power, then they are going to drain what the mobile phone that they are going to be operating on. All the time the mobile phone will be running low. Then I spoke about the embedded processors, which we spoke about. Now we have some washing machines too. So the washing machines also have the embedded processors, which are basically used for following the same process, wash, and that's it. So any question before I continue? Any question? Am I moving too fast or it's okay?
Hello, sir.
Okay. Yes, sir.
I wanted to ask that if you want to buy a new PC, can you also consider the computer refresh rate as well?
Yeah. You can look at all those things. That's why I said that when you're buying a computer, the CPU alone, I mean, initially, the CPU alone doesn't guarantee that you are buying a good computer. The other things also comes in. The memory comes in. The as we are going, we'll cover all of them. So you have to look at, so if it's you are a graphic guy, okay, you're a graphic guy, then you have to look at the refresh rate of the PC you are buying, the laptop you are buying, how the screen looks like if you are a graphic, because if you're a graphic designer, you have to make sure when you are choosing color red, it should be red. Okay, there are some screens red will look like orange or some color. So you may be designing and you are not getting the correct color because the refresh rate and the pixels are not correct, are not that good. Maybe that machine is meant for typing. Someone will be doing work, who will sit in the office, they'll be. Okay. But if you are a graphic designer or a video editor, you have to look at all those things. If you are a gamer, you have to look at all those things. That's why we have monitors. We have some monitors that are very expensive, 4K monitor. They are even expensive than television. You ask yourself. Even currently, monitor is expensive than TV. If you look at a 32-inch TV, 32-inch TV, which you can use it for everything, it's been sold like 800, 900, less than 1,000. 32 inches monitor is around 3,500. Just monitor that doesn't do anything. You can't use it to watch TV. You can't use it to watch movie. You can't use it for anything. Just monitor. It's expensive than what TV. Even if you compare a 4K TV and a 4K monitor, you realize the monitor is much expensive than TV. So there are some people, because they know monitors are expensive. Instead of them buy monitor, they buy TV and they use it in their offices. So they'll go look for TV and use it as monitor because no after then they connect it to their system in it and they are using it. They have TV pole on it. When they want to watch TV, they use the remote to switch from what? HDMI to what? DTI or anything, then it's just watching TV. But monitor is expensive. So all those things comes in. That's why I said depending on the user, what you want to achieve. Okay. So as I say, the processor is not just, you have to look at the memory, you have to look at the storage, the hard drive you are using, and other stuff. All of them work together for you to get what? A very efficient system. Okay. All right. I'm sure maybe after, because we've not gone that far, I'm sure as we go in, those will come in. The question you're asking now will also come in. All right. So processor have its evolution. Okay, some you can go and watch online, go to YouTube, and you can look at the processor evolution. So the processor evolution started earlier um when ICs, okay, was mounted on chip, whereby we are able to build a processor speed which a small chip which has the same speed as like a supercomputer in a vacuum room. Okay, so that's when the processor started, when we started using the IC. Okay. Now there was this man Moore's law, which in the initial genesis or evolution of processor, he made this assumption that every 2 years a computer is going to have a processor speed. Like every 2 years, computer processor speed is going to double. We're using the DOS. I don't know if any of you have used DOS before. Me, I started using DOS before Windows came into being. So DOS, then it came to Windows, I think Windows 98, 95. Windows 95 came first, then 98, then 2000, I think 2002. Then Windows Millennium came. Then from Windows Millennium, then I think we jumped into XP. From Windows XP, then we have different versions of XP. Some people were pirating XP, so we have different versions of XP. But all that time, dual core didn't exist. It was the normal Pentium in Cerilon and the normal Pentium processor that was there. So you realize every 2 years, another Windows will come. And you know that processing power is times 2 the earlier version. another computer will come, and the OS that was coming needed the higher version of processor. So, and then it's difficult to even get a processor that is running 1 gigahertz. All the processors were running megabytes, 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 megabytes. Okay. So you realize that 200 megabytes, the next OS that comes will need a minimum of 400 megabytes. So the processor was what? Was just this law was applying. Until they got to a place they noted that the law doesn't work again. When we started using when we got to the dual core, when we jump from Windows, from SP to Vista came first. Those of you who are IT guys knows about some of this OS. So from Windows, the versions of Windows, different versions, Crystal Windows, different ones came. Then we jump toward Vista, Windows Vista. Windows Vista was running on this kind of processors, but it was struggling. So from there, they noticed that the more law would not work. Then that's when they decided to what? Advance and expand and started introducing the multiple cores to support the Windows Vista. So Windows Vista started running on multiple cores, not dual core. And then dual core was the top notch. If you have dual core, you are the boss of everyone. Okay. So this law was broken. When was the dual core? Well, the dual core came very fast. No, then the quad core came. The years that they anticipated, now everything was happening fast. So some of these laws have been broken because of now the event of AI and other stuff. Some of the things that were written, they wrote that they thought it will happen some years to come, have already started applying. So some of these laws basically got broken on them. So when dual core came in, they started to use advanced technology to what? Do dual core, whereby the processor will still maintain, but we are going to have double chips in it. Then we started having, so from Vista, then Windows 7 came in. Okay, Windows 7 came in, and that's when the Core i3 and the stuff started coming to support the Windows 7. Then for Windows 7, I think we have there was one OS that came, I've forgotten, but it didn't keep long. Then Windows 8 came in, then 8.1, then Windows 10, and now we are at Windows 11. Okay, so that's the evolution of the processing power. Initially, it was stated that every 2 years, historically, transistor density of memory will double approximately 2 years, and that runs from the DOS era up to the time what Vista came into being, and they noticed that it can't run again. So this law was what broken. Okay, so basically that's the history, the evolution of processing power. So you can go to YouTube, just type evolution of processing power, computer processing power. You may see a couple of videos, maybe explaining with videos, which you can listen to it, then understand it better. Okay. All right. Also, I have some lecture notes here, which lecturer notes, which you can read sometimes to understand what the diagrams that is being put. Spoke about this one already. Speed, number of cores, power consumption, cost, and what compatibility. So these are the 5 factors which I've already. I didn't know I even have it in the slide. So that's it for that one. Now let's jump to the memory system. Now we are done with what? The CPU. We've delved into the CPU, inside the CPU. Then we look at the type of processors and what they do. Now let's go to what? The primary memory. So when we talk about the primary memory talks about 2 types of memories. Okay. So primary memory talks about what? The RAM that we all know as the random access memory. And it talks about what? The ROM, that's the read-only memory. So the 2 memories add up to become what? The primary memory. So that's the primary memory for a computer system. So if you are asked of primary memory, I know somebody will only be thinking about just the RAM or the ROM. Primary memory is talking about the 2 of them. Okay. to make a computer run faster or become much efficient. The memory also serve what? Part. That's the primary memory. As I said, the primary memory is in what? Two types. Okay. So the primary memory or the memory is an essential component of a computer system. That it stores data and instructions needed to be what? Processed. It also works close with what? The CPU to ensure that information is available when what's needed. Without the memory, if I'm saying the memory, without the primary memory, so that you know that I'm talking about the two. Without the primary memory, the CPU will not be able to perform any meaningful operation because it will not have any access to any data or instruction. So the CPU there is there, but it needs the primary memory in order to execute. If the primary memory is not there, the CPU itself can't do anything. It's just sitting there. Okay. The moment, use different types of what? Memory. And we have what? For if you want to check a memory, there are certain things that you need to look at. So the memory types vary from what? The speed, the capacity, the cost, the functionality. So all those things are things that makes memory varies. Some depend on their speed, some depend on their capacity and how expensive it is. Okay. Also, just keep in mind in the CPU, I want to see if you are following the CPU. What serves as the memory? Anyone can answer. Which part of the CPU serves as a memory? Which part of the CPU serves as the memory? The component of the CPU. Anyone? Solomon, I think you're Solomon. Solomon, do you know the answer? Because I think your mic is on. What about Richmond?
Register.
Okay, Solomon, which one? Which part of the CPU serves as the memory?
The register.
The registers. Okay, good. Thank you. So the registered, we spoke about the registered as memory inside the CPU. Then we have the what? The primary memory. But the registered is small, is very small, and stores things that the processor is currently working on temporarily. Now, when you come to the primary memory is bigger than what? The register. What the primary memory does is it keeps data which is next in line to be worked on, waiting for the processor to come and pick. So that's the difference. The register keeps in memory instructions that are currently being worked on, while the primary memory keeps instructions that are next to be worked on. Now, the primary memory is bigger compared to the register, so it can keep a little larger information or instructions compared to what? The registers. Okay. And also, just keep in mind, the registers is expensive. Even though it looks small, it's expensive than what? The primary memory. It's expensive in a way that the size that it's like the space that or the capacity that it has. If you should factor its cost and you compare it to the same size of a primary memory, then you notice that the register is far expensive. We are going to the latter part. So now look at the error keyword and we'll see so that we explain it better. I'll explain better for you to understand it. Okay. So that's for the primary memory. Access memory. Then we have the ROM, which is the read-only memory. Now, the random access memory, which is the RAM, is the RAM memory that is like a card. That I think when I came to campus the last time, I removed one from the computer. What it does is it stores data and instruction that is meant to be processed. Now, one thing I want you to also, even though we've not reached operating system, Okay, but let me put it in there so that when you get to operating system, then maybe I expand it. From the time you on your machine, anybody, the time you on your machine, anything you do on the machine is being done on the RAM. The RAM. Anything you do is done on the RAM. Some people think it's done on the hard drive. From the time you on your machine, the OS operating system, when it's booting, it copies the OS onto the RAM. When you open VLC, it is open on the RAM. When you are copying anything you are doing, when you are playing movie, anything you are doing is done on the RAM, not on the hard drive. So you can have a computer without a hard drive, and you can store. I don't know if we have any IT guy who have run a computer without a hard drive before. You can create an OS on a pen drive and connect it to I'm not talking about OS as in formatting a laptop or formatting a computer. You can I used to have a pen drive, a OS that's a fully functionable OS with drivers, everything installed, with software, everything onto a pen drive. You connect it to a computer without a hard drive, start the computer, then tell the computer to boot from what? The pen drive side. As soon as you tell it to boot from the pen drive side, it's going to boot and copy that particular OS on the pen drive onto the memory, and you can run the computer without a hard drive. How many of you have done that before? Can you raise your hand or type 1 in case you've experienced that, or you know about that, or you've done that before? Because I know we have a couple of IT guys in the class. No one has done that before. Okay, so if you don't know, we call it Windows on the go. So you can write it somewhere. Windows on the go. You can even use a software called Refuse to do that. You set it. Usually, people use Refuse to format format a pen drive for maybe formatting. You put a Windows on it to go and run installation on a computer. But you can set it as a Windows on the go. So what it does is, it's when you are installing OS on a computer, you usually copy the files, you install the files onto the hard drive. So when you are doing it on the Refuse on the go, then the files are rather copied onto the pen drive or the flash drive you have. Or you can even use an external hard drive, and that becomes your hard drive. The only difference is that this hard drive, you can move it around. And the other one, what we do is the hard drive that is inside a computer. So anytime we try to boot our computer, it really goes to the hard drive and boots the OS there onto the memory, and it starts with it. So if you have the OS on a pen drive or a flash drive or an external hard drive, you can redirect the system to what? Boot from what? The particular external drive or flash drive, and it will work perfectly. So those of you who are IT guys, and if you don't know about it, I've let you know. You call it Windows on the go. Try and read about it. Look for Refuse. Search online. Try it. Get a pen drive, 16 gig pen drive or 32 gig pen drive. Run it on it. Try it and see how it is. And it's very, very, very nice. If you are someone who troubleshoots a lot, it's easy. You go to someone's computer, the person has a lot of virus, you just slot it. Or maybe the person's Windows is corrupted or something. You just slot your drive and you are good to go. You have your softwares. You want to run with it. You just connect any machine, you just connect and boot, and you have your files intact. You don't need to use someone's files on your machine. So that's it. So what I'm saying, when you boot your machine, everything comes onto the RAM. So that's the RAM. So the characteristics of the RAM is that one thing you also have to know that the RAM is volatile. When you say RAM is volatile, it means it stores things temporarily. When you are running anything on it and there is light out or the computer shuts, everything you are running is stored. It's not stored. It loses it. Okay, it loses it. So it's volatile. It doesn't keep anything permanently. Okay, that's why when you're on your machine, all of a sudden you are using a desktop and there's light out and you don't have UPS. All the time you lose everything. When you come back, you have to reboot again. It's just maybe some apps. If you are running some apps have automatic saving that it saves behind the scene. So you can recover to that time. And it saves it onto the storage, the hard drive, so that you can recover it. Sometimes it stays into what we have what you call the temporal files somewhere. Then you can restore it. Okay. So it's volatile. Okay. Then another characteristic of what RAM is that it can be written on, it's not permanent. Everything on it is not permanent. You can write new things on it, you can change new things on it. You can play, you can open a video which is running on the RAM. You can just close it and change it with what? A browser. You can just close it, change it with music. You can just change it and it's open what? A game. So information on RAM can be erased and changed anytime, as far as this, anytime, any point in time. So that's the RAM. Then we have what? ROM, which is the read-only memory. And the ROM is on the motherboard. Okay. The ROM, you can't take it out. It's not something you can remove and replace. It's the RAM which you can remove, upgrade it, and you can replace it. It has its own slot. But for the ROM, it's static. It's on the board. Okay. So the ROM stands for what? Read-only what? Memory. Okay. And it is what? Volatile. When you say volatile, it means what? Anything that is on it is permanent. Okay. It's why we have different types of ROM. Okay. But at the moment, things that are on it are what? Permanent. And ROM do not have huge memory capacity just as RAM. So it's one difference when you are going to differentiate between RAM and ROM. The ROM do not have huge capacity. It can be upgraded as like updated in terms of increasing the capacity. But RAM, you can update the capacity from 8 gig to 16 gig to 32 gig to 64 gig, how you want it. But the ROM, you can't do that. Okay. Then also, what the ROM does is what? The ROM holds instructions that the computer needs to start or boot. So when you are booting a computer, all the instructions when you on your computer, I mean those who are using desktop a lot, you see maybe the computer logo will come, then you see press F1 to do something or F2 to do something. Then sometimes some computer you see some that set instructions running, then the computer will start booting. All the instructions the computer need at the beginning to start and run, then those instructions are on the what? The ROM. So without the ROM, you can't boot what? Your computer. So you notice that those things that are negligible are rather the things that is really powering everything, not the other stuff that probably you may rather focus on. So the ROM what starts everything. It keeps everything, including the system time and everything. Every setting that have been set on the computer, in case you put in a BIOS password, you've put in, it keeps everything. So it starts everything with what? That particular instructions. So that is for what? ROM. Okay. Now with RAM, we have different types of RAM and we have different types of ROM. Okay. So let's move to RAM. So RAM, we have what? Two types of RAM. We have the dynamic random access or DRAM, dynamic access random access memory. We will call it DRAM. Then we have what? The SRAM. Okay. So explanatory, the dynamic access memory stores data using capacitors. It requires continuous refreshing to maintain information. So for that one, usually the devices or the machines that have it, when you store something there, you have to always keep on what? Refreshing. If you don't refresh, the things will not. So you always have to keep on refreshing to maintain what? The information. Okay. So when you save something, you have to refresh to maintain the information. Keep refresh. So that's the RAM. And that's not what we usually call is what cost effective with large what storage capacity. But that's not usually what we have on our computers. The one we have on our computers are usually the SRAM. So just keep in mind, what we have on our computers is what? The what? The SRAM, not what? The DRAM, not the dynamic. So the SRAM what? Store data using what? A free-form circuit does not require refreshing. Faster and more expensive, typically used in what? Cache memory. So we'll look at cache memory later. Okay. Then I think over here we have what? The memory capacity. So we have a low memory capacity. So if your computer is running a memory of 4 gig, a RAM of 4 gig, the computer struggles because when you boot your computer, boot your machine, the OS will run into the computer and take a particular space. If the OS takes, let's say, 3 gig, then it means you only have 1 gig free space for the computer to what? Operate on. Now you open VLC, VLC will also take like, let's say, 100 megabytes. Then you open maybe Photoshop, which is almost going to consume everything. Before like the machine is slow. When you click, it doesn't click. You are dragging, it's not dragging. Okay. But if you have higher memory capacity, then if the OS take like 3 gig, you have like, if you have 16 gig, you have other gig to handle what? Video editing and the rest. So I think I want to do something here. Okay, I just opened the task manager so that we look at it on the screen here. Okay, so this is the task manager. Okay. All right. So you can see we have what? Processes over here. The machine I'm running is running 32 gig RAM. Okay. And you can see that even with 32 gig RAM, see 47% of what the memory has been used is being used over here. Because I've opened a lot of things are running behind the scene. So I'll have what 47% of what the RAM is being used at the moment. So if it's not a 32 gig RAM that I'm running, then if I was running 16 gig RAM, then it means the machine will be struggling at this point in time. And most of us have been saying that in a lot. And one particular thing that usually lets our machine run slow is basically browsers, Chrome or Mozilla. We are used to what? Opening different tab and different tab. If you can see, look at the Mozilla. Mozilla, I've opened like 25 tabs. It's jumping, 25 tabs. See see the space it has taken, almost 2 gig. The rest are taking megabytes, megabytes, megabytes. The Mozilla has taken more space because I've opened it tab, 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 tab. And most of us, that's what we do. When we open our browser, scroll, we open new tab, new tab, new tab, new tab, new tab. We don't want to close any of the tab. And we know we'll not even go back to it again. But we still, some people can even open up to like 50 tabs. When they open their browsers, you see the tabs small, 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 small at the top. And all those things put stress on the computer memory. Sometimes you are forced to restart the machine. Some people, they will end up closing all the tabs. Then as soon as you close all the tabs, you notice that the memory will be free, and the computer will start responding faster. Okay. Then I have my disk storage and the rest. Okay, so we have this one here. So just let me close this and let's continue. So as I said, if you have huge memory, then you may have what? After the OS runs on the memory, you may have a lot of space to do other stuffs on what your. Now, apart from the RAM, we have different types of ROM too. So we have the 2 types of RAM, and we have what 3 types of ROM. So the ROM, we have what the PROM, that is programmable ROM. Okay. Then we have EEPROM, that's is erasable programmable ROM. Then we have EEROM, that's what electrically erasable ROM. So these are the 3 types of ROM. But the ROM that we have on our system is the last one. On our computers is basically the last one, the EEPROM. Okay. So let me which can be programmed once by the manufacturer, and when it is programmed, the data cannot be changed. So that one is permanent. So those are also on the board. From the time the manufacturer will program it, set certain instructions to it, and you can never change it. So we have that one there. And we have this one too on our computers, on our various laptops. We have the PROM, and majority we have the PROM and what? The EEPROM. Okay. Then we have what? The EEPROM. No, we have the ROM PROM and the EEPROM. Some of our computers. Then what? The EEPROM, the result programmable ROM can be erased and reprogrammed using ultraviolet light. This allows for what? Updates in the data, in the stored data. Updates for stored data. So this one, it can be erased using ultraviolet light and can be programmed. So this one is not on our computers, but probably it will be on different kinds of what? Computer system, which you can use the ultraviolet light to just erase it and you are good to go. Then we have what? The EEPROM, which is what? Electrical erasable programmable ROM. The electrical erasable ROM can be erased and reprogrammed using electrical signals. This type of memory is completely used in our modern system for firmware updates. So you can notice that some of you can even update your BIOS of your computers. Sometimes when you go into you are running maybe Dell or HP, you format your machine. Sometimes you want to update some of you don't get some of the drivers, you go to the you download, you install. Sometimes you're even scared to install it because sometimes you feel like when you store it will damage your computer. When you install it, after that, it will restart the computer. Then you notice that it updates the firmware. Sometimes while you connected to the computer, the internet, then the system runs automatic updates. Then before you realize, the system will tell you you should restart. And when you restart, they'll tell you because it's updating the firmware. You don't need to distract it from updating it. So that's the one we have on basically most of our modern laptops and computers have that one, where we can sometimes update the firmware of the whole computer to upgrade it so that it can support more things in terms of expanding the storage and reprogramming, adding certain things storage. Okay. And this can be done, and it tells what you can always update it usually by accessing is when you on a press F1 to enter BIOS, some F2, some F10, some F12, depending on the computer you are using. When it takes to the BIOS gives you the interface where you can interact with basically most of the hardware components. You see the hard drive you are using, the size, the brand, the name, the capacity. You see the memory you have, maybe sometimes the name, the storage size. You see the network adapter you have, if there are two, the wireless adapter. There are a lot of things you can see in the BIOS, and you can configure it. If you have a hard drive and a system hard drive, or the hard drive first before the CD-ROM, or memory card pen drive first before any other things. So you have the chance to reprogram the ROM. If you are doing that, you are reprogramming the ROM. So when you go to the BIOS, you are having an interaction with what? The ROM. And you are reprogramming it because we are using what? Most of the computers are using what? The EEPROM. So you can just reprogram it, readjust, reassign, rearrange it in how you want. You can even disable certain things. Then after that, you save. Then the computer keeps that as this now. The ROM keeps that this now how the ROM has been programmed. And it keeps it until you go back there to update it. Okay, so I think when we get to OS, we'll look at some of these things. I'll find ways and means for us to do it practically so that some of you who probably don't have idea about it will get to know how it is done. Good. All right, so that's it for the types of ROM. So we now have what? RAM versus ROM. So that's the relationship and what? The differences. So when we come to RAM what? Acts as what? An active workspace, that's read and write. ROM holds what? Essential startup firmware, that's the read-only. Then when we come to data performance, RAM is volatile CPU interaction, it stores current running program or apps or data. Okay, so as I said, everything that you are running is being run on the RAM. Then when you come to ROM initiates the computer booting process, which I also explained earlier. Then we have the subtypes, we have the DRAM here. Then so we have the DRAM and the cache. I think we'll come to the cache later. For our experience later when I think some of the slides have talks about cache. They will talk about that one. Then we have what? Then so I think that is basically the verses. And I think when you go through the book, you can get to know more differences. In case the differences are asked, at least you know what to put in there. Now let's come to the relationship between what? The RAM and what? The CPU. So with that RAM, we did the CPU earlier with that RAM. Now what's the relationship? Okay. So the CPU and the so the CPU retrieve data and instructions from the memory, process them, then may store them back into memory. So that's what it does. It takes the CPU can't access anything on the hard drive. Okay, the CPU don't access things on the hard drive. What it does is only access things from what? The memory. Then after accessing it, it executes it. After executing it, then it takes it backward to the memory. And it does that multiple times, like just does it in memory. So it stores back in the memory. So when it does that very speed, so how fast the processor is and the memory is helps for the processing to go very fast. Okay. So if the speed of the CPU can access the speed at which the CPU can access memory depends on what? The capacity or what? The CPU and also the speedness of what? The memory, how fast the memory is. Memories also have its own speed. So when you take the actual RAM, the RAM has they have inscription on it. Sometimes they write the speed on it. I have one here which is okay, I can't see the speed. But usually there is speed on the RAM. Okay. So all RAM doesn't run at the same speed. So if the RAM has a very higher speed and the processor is also very speed, then it speeds very fast. That's why someone using probably i7 whose computer will be fast doing stuff compared to someone using an i-Core and i3 or probably i5. Okay, so do work what? Hand in hand. So over here we have the diagram whereby the CPU processing speed. Then we have what? The memory delivery speed. Then the bottleneck risk. So if memory delivered data slower than the CPU processing it, the CPU sits idle, wasting what? Cycles. So that's what I say. If the CPU is moving too faster than the memory, the CPU go access things goes because it's doing that extremely fast. So if the memory can't move in that speed, then which is the CPU. This brings us to the point where the cache will come in. Okay. So over memory processes it and writes results back. That's the first one. The multi-level solutions. Modern system introduce intermediate high speed. Okay, that's the cache. Okay, so I'll talk about that one. Then we have the speed dependencies. Overall system performance is detected heavily by memory speed, not just the CPU clock speed. I hope you are following. So the CPU clock speed is when it goes one, come. So that's the clock speed. So if it's going faster, it's just like running a baton. Okay, you are fast. You are fast. You run your baton, you get to the point to add on give the baton to your next person to continue. You go there and the next person is not ready. So you have to wait till the person comes before you give it to him, before you continue. So that's the same thing. Now, in between the CPU and the memory, we have our modern computers have what we call another storage, which we call the cache. So the cache is in between the RAM or the main memory. Let me use the main memory. The main memory and the CPU. Okay, so they are in between. Now, what the cache does is for the computer to run very fast or for it to move very fast, what it does is when it's accessing things or data from the RAM, the system automatically push the next thing into the cache memory. And the cache memory is between the memory and the processor. It's just like, let's say Kwame is standing at point A. Okay, Kwame is standing at point A, and Kweku is standing at point C. Kwame needs to get something from Kweku. Then we have Amawiz in the between of Kwame and Kweku. So what they do is, instead of Kwame always going to Kweku to pick the thing, Kweku will bring the thing to Ama in the middle. So that when Kwame gets to Ama, Kwame can access the thing and return instead of driving all the way to Kweku. And that's what the cache memory does. So because the system is programmed in a way, when the CPU accesses the memory, and the memory is an array, so it has two ways in which it does that. I think later we'll look at it when we are looking at the hierarchy, the concept of the cache memory. Okay, so what it does is when the system come and pick something at point A, the memory picks something at point A. Are you following? Then after pushing point B, it also pushes something. So when you are playing music and you put for repeat 1, you notice that it's very smooth. You've done iteration. So the computer don't need to go to the memory to access that song again, because that song is in the cache memory. So it will be moving smoothly. Also, if you observe, in case you are playing music and you have different tracks, maybe track 1, track 2, track 3, you are playing track 1. You notice that sometimes when you click on next to place to track 2, it moves smoother than you jumping to go and click on track 20. Have you noticed it? Have you noticed it?
Yes, sir. Yes, sir.
Yes, so the system understood that since it's playing track 1, the possibility of you playing track 2 is high. So it pushed track 2 to the cache memory, so that automatically, in case you decide to skip, it just flow. But in case you decide to go to track 30, then the system will know, track 30 is not in the cache memory. Then the CPU has to go back into the memory and go and look for track 30 or track 40 and start playing it. And that's how the cache memory works. And it helps so that it's lower the speed in which data is accessed, so that your computer will be faster. Okay. And I think the book has explained it much better. Okay. So the cache memory too also have levels. You have level 1, level 2, level 3, where things that are accessed frequently go to level 1, the next one goes to level 2, and the next one goes to level 3. And that brings us towards the hierarchy of the memory, how the hierarchy runs. So we have the master hierarchy. We have the first level, which talks about the CPU registers, and that is what the first memory in which the CPU accessed. Okay. Now, when the CPU accessed the first memory, the next memory it accessed, in case it wants to program work on something, it looks at what the cache memory first before even going to the main memory. So when the CPU is working from the registrar memory, it jumps to the cache memory. If it checks the cache memory and there's nothing there to work on, or there's no instruction there, then it moves into the main memory to go and pick what the information and come and work on it. But if there is information or instruction in the cache memory, that's what the CPU works on immediately. Then if it comes to the main memory and there is nothing there, then the CPU jumps towards the storage, that's the hard drive you have, to go and pick it, bring it to the main memory, move it to the cache towards the registrar. And that's the cycle. Now, the diagram lets you know that from here, from level 4 to the top, increases speed and cost. Okay, so the CPU, over here, the speed is more, the level 1, the speed is faster compared to the speed here, because it has to just, this one is inside the CPU itself, so it works faster. This one is outside, so it has to jump. And the hierarchy just works like, let's say, let me explain the hierarchy in the form of, you are a chef. Then you are preparing a food. You are preparing any food of your choice. Now, on your table, the food itself is what? The food that you are preparing is, when you want to make something, you already make something, and that's the registrar, and you are preparing. It's on fire. Now, the cache memory is just like the ingredients you have on your table, that instant table that you are preparing. So, in case you notice the pepper is not too much, you just raise your hand and pick the pepper and pour it in it. If you think the salt is not that much, you just, so the cache memory is what is on your table. Now, the main memory is just like something that you have on the shelves. Do you understand? So you notice, oh, something that you want to add something is on the shelves. So now you have to go a wider distance to the shelves, go and pick that one and come. And that one is what? The distance becomes what? A little longer compared to the things you have what? On the shelves. That's the cache memory. Then the storage one is, you notice that, hey, you're supposed to add hunger. You forget hunger. There is a store in front of your house. And that's the what? Secondary storage. That's the hierarchy. The one that is closer to you, you access it faster. If you don't see it before you go to what, the next step, to access the one that is further. If you go to the further and it's not there, then you go to what? The next. Because I don't think if you want hunger and you have hunger on your shelves, you leave the one on your shelves and go outside and go and buy it outside and waste time. So that's really the hierarchy. And that's how the computer system operates. Also, from the top to down, you'll notice that even though when it's going up, the speed increases, but the cost is become what? It's more expensive. That's the same way when you are coming down, the capacity also what? Increases. So over here, the registrar, you can have a little megabyte in bytes. Then the cache memory, you can have a little bigger kakra. Then we have the main memory where you have 1 gig to up to like 32 or 62 gig of RAM. Then we have the storage that you can have terabytes of storage. So that's what the hierarchy. Okay. Any question on the hierarchy? Any question?
Yes, sir.
Okay. All right. Do you
Sir,
have a
can you hear
question?
me?
Yes, please.
Yeah, that's which one?
Okay, which one?
Yes, please. I want to ask that the hierarchy, as you have explained, it used to assume that the register capacity is always very let me say low. So for a computer CPU to have a higher register capacity, then it means that doesn't mean that the price of that computer is going to be higher.
Yes. Yes, that's what it means in cost, because
That's the cost, yeah.
yeah, that's the cost. So that's what it means. So for a register to have a higher register, for a computer to have a higher registers capacity, that means the processor needs to be big or to be huge.
Yes. Okay.
And that's where the dual core, because I think Core i7 laptop is expensive than Core i5. Are they like?
Yes.
i5 is expensive than i3. It's because of what? The processor.
Okay.
Because automatically, if the processor is huge, then you are going to get huge what? Registrar space to keep listening. So that's why I said as it goes up, it becomes what? More expensive. All right.
Thank you.
I hope I think it's good you brought this question so that at least maybe someone also have the same thing in mind and we've cleared that. All right.
Thank you, sir.
All right. Okay, so I think we've already looked at this, where I think the pictures of the RAM and the processor. So I think we've done this one already. So the registers are inside the processor. So it's different from the RAM. So the register is inside the processor, inside the chip. Then the RAM is outside that register. So I think that one we've already tackled that one already. Now let's look at what we call the cache memory. Okay. So with the cache memory, that's three layers: cache 1, cache 2, cache 3. Which we have what? Cache 1, which is smaller and faster, because that one is closer to the CPU. Then we have cache 2 and cache 3. Cache 2 is a little bigger, cache 3 is bigger but slower. Okay, then we have the main memory. But this one there in the board, you don't see it, but it's the process if it goes. Now, there is one key word that you need to know. We have what we call cache hit and cache miss. Okay. Now, when the CPU, I told you when the CPU is processing, it first goes to what? The cache to check if there is something there, an instruction there that is there for it to process first. If there's no instruction, then it goes to what? The main memory to go and pick the instruction and come to work on. Now, when the CPU goes into a cache memory and it says instruction, there's something there for it to work on, then we call it what? A cache hit. Okay, so the CPU successfully file record data in the cache, allowing immediate zero delay access. So it's instant. So cache hit. But when the CPU goes and there is nothing there, and it is because there is nothing there, the CPU is miss. So it says the data is missing, forcing the CPU to suffer a delay while retrieving it from what? The main memory. I hope this is also clear. So over here, I think the lecturer have said what? Cache memory is the what? Condition, waiting for the CPU to access it. So that's what the So I think the cache hit and cache miss, I hope it's understood. So I think if you are supposed to explain it, it's easy for everyone to explain the cache hit and what? The cache miss. All right. So let's look at the time. Okay, so we have someone who asked that we'll be talking about the cache hit, cache miss, cache. I think I explained earlier that how do the computer or what's the concept? How does information moves from the memory to the cache? How is it done? which process does it done? Because you made them know that the information, the data will be moved to the cache for the computer to the CPU to access. How is it done? Okay. So the core concept is that program do not access data randomly. So computer do not access data randomly. They access localized set of data predictably. Cache memory uses this rule to preload what? The data, which I explained earlier. So that's the locality of reference. So there are two types of what? The locality of reference. So we have the first one, what we call what? The temporal locality. So the temporal locality refers to the use of the same data or instruction within a short time. So that's what I was talking about, the iteration, repeating a song. So for example, a loop of program repeatedly executing at the same instruction. So when you put the song on repeat one or loop, okay, then it goes to the temporal locality. So it's time based, so it keeps looping it. So the system will put it to the cache memory and it is there. So that's the first way the system access the what data into what the cache memory. Then we have the spatial locality or the spatial locality, and this one refers to what? Accessing data that is located close to what? Recently accessed data. Okay, for example, when reading elements in an array, or we all know array, you've learned something: number 1, number 2, number 3, number 4, number 5, number 6, number 7. The system suggests that since the thing is in the array, and also things are stored on the hard drives and memory in an array form. When you look at how the memory is structured and in the structure of it, it's in an array form. So when it access something from point 1, it provides that, oh, as far as the system has accessed point 1, the next step is point 2. So just let me take the point 2 and go and put it somewhere, waiting. If it comes and it doesn't want it, fine. And if it wants it to, praise the Lord. So it uses the spatial locality that if data is pointed at a nearby memory, so the nearby one is also what? The next is also accessed and pushed to what? The cache memory. So it uses these two concepts. Okay, so these are the two main concepts in which data is transferred from the RAM to what? The cache memory, waiting for the CPU to access it. All right. Now the storage. So from the hierarchy, we saw there's what? The storage. That's the last part. Okay. So the storage, that one there we all understand. Okay. So with the storage is the last aspect where we are talking about either the hard drive or what? The solid state hard drive or cloud. So sometimes some of you on your, if you are using Mac or even on your computer, if you are using Windows, sometimes when you are saving something, it even gives you option to store it in the Microsoft. If you have your Microsoft account, that's even the first option that you can store it on your Microsoft account first, or you can choose to store it locally. So when you are deciding to store something outside your machine in the cloud or somewhere else you can access it, which is not on your machine, then we call it storing it on the cloud. So when you say cloud, we are not talking about the cloud in the sky. We are just talking about storing something or accessing something outside your immediate device you are using. Anything you are accessing is not on your device. You are just accessing it elsewhere. So you are accessing it in the cloud. Okay. So that's the story. So hard drive, solid state, and cloud, they also help in what? Making how efficient the machine is. That's what I'm saying. If you are running a regular hard drive, the old hard drive, and someone is running the solid state hard drive, the person running the solid state hard drive machine will be faster than yours because it's easier for the processor to pick information on the SSD. It's easier, it's faster compared to the hard drive because the solid state uses chips and the normal hard drive uses disk. Okay, it uses disk. I don't know whether maybe later we'll talk about that one as we go ahead. It uses disk and this one uses chips. Okay, so you can access it faster, and when the CPU can access information faster on the storage or hard drive, then it will also go in hand to make the computer faster. And that's it. So I think when you go through this one, self-explanatory. Okay. So finally, this is the finally, bridging the speed and gap. So this is just basically, in conclusion, CPU processes data in millions and times faster than what secondary storage can deliver, risking severe what system what bottlenecks. So that's it's one of the challenges. So fundamental challenge, because the CPU is faster, if you don't have what a storage that can deliver at that speed, then automatically it's going to hindrance how fast what your machine works. There are some people, they have a computer, their computer is slow. You take it to a technician, they tell you change memory, upgrade memory. And you'll be upgrading memory and still the machine is still slow. Sometimes it's the hard drive. As soon as you change the hard drive, you are okay. It's not everything that is memory. So as an IT expert that you are, you have to know the dynamics that it's not all the time that is a computer is slow, it's the memory or the processor. Sometimes the hard drive. And the hard drive is something that sometimes you don't even think about. Before someone will think of the hard drive, unless maybe when you on the machine, the hard drive makes noise, then you say, oh, the hard drive is damaging. Then that for the person would think that, oh, it's the hard drive. Or sometimes when you boot the machine, sometimes it doesn't boot. It will tell you OS not found. Another time it boots. Then you know that the hard drive is failing. But there are some machines that the hard drive is working perfectly, but still it has what issues. Okay. So that's it. I was having a external hard drive, which is very, very good. I'm sure maybe the next time I meet you face to face, I'll bring it to campus so that those who probably may need the technicians. What the external hard drive is for a technician, when you put a hard drive in it, you can buy external hard drive and install hard drive in them and use it as external. When you store any hard drive to it and you power it, it's going to give you, it has an AI that's going to show you the speed of the hard drive, the health of the hard drive, the number of hours in which the hard drive has been used and other stuff. Then to tell you the total strength of the hard drive. So it can give you 80%, 85%, 70%. So as a technician, if the machine it gives you, then you know when sometimes you are diagnosing a machine, it will help you to know whether you really need to change the hard drive or the hard drive is working 100%. It's just like buying a car, which you have to check the odometer. Okay, you look for the mileage. If the car has run like 500,000 miles, 800,000 miles, you don't want to buy that car because you feel like the car has overworked. Okay, but you look for the one that the mileage is slow, and that's the same thing that sometimes happens to what the hard drives. Then we have what the hardware solution. So this is basically what the summary. So in conclusion, the memory hierarchy is a key concept that connects the operation of a CPU with the storage capabilities of the computer system. By organizing memory into its different levels, computer system can what achieve balance between what speed, capacity, and cost. So basically, this ends our section for today. Today I didn't move very fast. I think we had 3 minutes to go. So if there is any question, I think I've spent the time correctly. If there is any question, the question can come. Sorry. The question can come, then we can end the section. Is there any question? Okay. So if there is no question, those who joined late, we spoke about, let me see. Those who joined late, we spoke about our next week, the final presentation that we'll be doing. So I'll be sharing the groupings with the course rep. The course rep will communicate with you, then we group. So that last face-to-face, we do our presentation on the last model. Okay. All right, so if there is no more question, I think we'll call it the day off. We'll be writing our first mid-sem during the asynchronous section. Okay. So the asynchronous section, we'll be using our time from and it's going to be an online mid-sem. And it's going to cover everything we are going to every topic we've treated before the asynchronous section. So I think before the asynchronous section, we have done how many topics? I think we would have done a number, I think 6 models or so. Okay. So just keep that in mind. We're writing our midterm in the asynchronous session for 20 marks. And the group presentation will be 10 marks, adding to be 30 marks. Then the final exams will be 70 marks. Okay. So
Hello,
I
sir.
think, hello, sir.
Please, sorry for cutting you. I want to ask this question. Concerning the CPU, you see, when you look at the system unit, most of the system, the CPU can be removed and probably replaced with a different one. But this modern laptop that is coming, you see that the CPU is embedded on the board.
Yes.
Now my question is, looking at the system,
Please.
yes. Let's say I'm using a Dell system unit, and
Okay.
I want to replace let's say the CPU is not working, but I have another Dell which is the same, having the same specification. Can I replace that CPU from that Dell to the other one? Or at what point or will it be compatible? Let me put it that way. Will it be compatible with a different CPU of the same brand?
Okay. So thanks for the question. As you said, so in the past, the CPU is not attached to the computer. Like it's not attached to the motherboard. You can remove it, install it, upgrade it. Okay. But the upgrade, you also have to know that every motherboard has its highest capacity. Even currently, all the motherboards, it has its highest capacity of memory it can take and the highest capacity of processor it can take. I used to those days when I was doing a lot of DOS, I used to have a DOS prompt which you can write to tell you the maximum capacity. And I think I'll look for it. Maybe I'll share it in the class sometime. I'll look for it. So currently, those days you can just change the processor. But with the processor, you have to make sure when you are replacing it, the processor have pins under them, and they've been modified in a different way. Some are smaller, some are flat, some are local. So if you are using a computer which you can replace the processor is replaceable, the system is replaceable, and you have another Dell machine, and you check the processor and it's the same thing, you can replace it to work. It doesn't matter if you are moving from a Dell machine to an HP machine.
Okay.
No, it doesn't matter. Because company, the processor they are using is Intel, coming from what? Microsoft. Do you understand?
Yes.
So if the processor is the same, it will fit. Then you can work which you tell it to. You don't have any issue. But that's why I say currently most of the machines that are coming now, they've embedded the processor onto the board. So if it has been embedded and the processor is damaged, then what you need to do is replace the whole board.
The whole board. Okay, sir.
Yes. That's what they want to make more money. So they realize that they were not making money. Even I know if they have chance, the memory card, they are going to right. So if there is no more further question, let me say
Hello, sir.
all right, sir.
Sir, this is Holy, please.
Okay, Oli.
Yeah, sir, please, I wanted to find out I'm currently out of the country.
Okay.
So regarding the exams, how is it going to be like, please? Or
Is it final exams?
let's say the mid-sem and then final exam as well, please.
Okay, so the midterm, mine is going to be online. So you can do it wherever you find yourself. So I think the last time I mentioned that I want all of you to download Safe Exam Browser. if you can give the link, save exam browser and install. Because my exams is going to use the safe exam browser mode. I will not capture your face though, but you need to have the safe exam browser before you can start my exams, so that you not be using AI to answer my questions. Okay.
Okay, sir.
So for mine, it will be online, but I don't know for the other lecturers. So if the other lecturers are doing, most of the lecturers will do the midterm will be online because you are distance students. So it will be maybe assignments and other stuffs. But for the exams, since you are not in the country, I'm sure when it's getting too close, we can arrange and see how best we can let you write it online, because we've been doing it for some students though. But you have to, if you are not in the country, you will be here while the exams. From now, after the Easter break, write a letter to ICDA and let them know that you are in the country, you are not in the country, and you are not sure you will be in the country around the exams time, so that in case they can arrange, so that they put it in their plans to add you to those who probably be taking in the online exams. And if you be doing online exams, before the exams, I may have like a 30 minutes or 1 hour session with you guys with how you can go about it, because you'll be doing everything online. You follow the rules, then if you are able to follow the rules, you are good to go. Okay.
Okay, sir.
Right.
Thank you.
So I think next week we'll be doing so we are done. Next week we'll be doing the storage device and data management. Then we will have what? Easter break, no lectures. Then we have what? Module 6, Module 6, Module 7. Then this Module 6, Module 7. Then we'll do our midterm around that time. We've covered a lot of modules. I want us to cover a lot of modules before the midterm, so that at least you have a fair idea how the exams will be like. Do you understand? At least 7 topics. So if the questions are in that angle, at least you may have idea about how the exam questions will be like. Then you do that. The presentation, they were prepared for exams. So I think our time is gone. Thank you very much, and we'll meet tomorrow. Study skills around 11, right? So we'll meet online tomorrow. So bye bye for now.